here. Hello, everyone that is with us. Welcome, and it's great to have you here. We are here today with none other than Gary, and I'm going to butcher the last name. Sorry about this. Ogasawara.
Just
Ogasawara.
that's very good. So yeah, it's very close to the Spanish type of pronunciation of the phonetics, but yeah, Ogasawara is very good.
Okay. Ogasawara. There we go.
Yep.
And none other than Bartholomew Farrell. And we are here to talk all things. Well, we're really going to be diving into what Cloudian has been up to and the storage. And so I'd like to just start, I think, with how I usually start things off by, Gary, you giving us a little bit of background on how you came to be the CTO of Cloudian. What was your trajectory like? How did you get into tech? What were you doing when you were a kid? And then what brought you here?
Okay, I'll try to keep it a bit brief. I mean, as a kid, I guess I've always been interested in problem solving, or I guess more specific way to say it is optimization. So how to how to do things right, and then with computer science, right, and programming, it was a very natural way to do that. It was sort of probably the early days of what we're seeing as AI, but I did my studies on decision theory and Bayesian decision theory, and that has been very useful. I mean, and then applied it to certain applications like autonomous vehicles and worked on ad servers and for dynamic ad placement, display ads, and then we got into sort of fast forwarding more close to where we are now. We got into working for wireless carriers, building their server software that would store all their messages and all their mail. And the hardest part of that problem, we soon realized, was the storage part. I mean, how do you keep all the storage? And especially for mail and messages, it never decreases. It always just, people keep adding more and more, and the economics, people want to drive down the cost. So that became a really interesting problem where we felt, or I felt that, the market felt the need, and there was a lot of interesting technology that we could bring to bear there. So at that time, maybe about in the 2010 timeframe, there was a lot of NoSQL type work, very, very good work going on there. It started with Hadoop, but also with Cassandra, which we use as a fundamental part of our architecture still today, and Mongo. There's a lot of very good innovation going on at that time, and we jumped on that, and it's been really good to start our tech stack and our work based on that level, because even today with our object storage product, we're competing with products that were developed or designed earlier, which I think hamstrings them because they're using not the most modern distributed computing techniques. So yeah, so started out as, we were meeting at my dining room table in my house, and then I grew the engineering team. Last year, we wanted more firepower in terms of engineering management, so we hired a new VP of engineering to replace me, and then I moved into this side role of CTO, but continue to do a bit of engineering products, and especially now focused on two things: Kubernetes, and the other is machine learning and analytics. So that's what I'm driving
Nice.
here at Cloudian.
Well, I know
Okay, and since
Bart
you
had
just
a
mentioned,
question.
yeah, you say, yeah, because since you just mentioned machine learning, to go back a
Mhm.
little bit, in terms of your academic background, UC Berkeley, you have a PhD. We could call you
Mhm.
Dr. Gary. That might be okay. That might not be. But specifically seeing that, just by coincidence, you focused on machine learning, but also uncertainty reasoning.
Yeah, yeah,
On a day like today, we've got a big election going on.
yeah,
There's a lot of
yeah.
uncertainty. Dr. Gary, can you help us out?
Oh, well, I have nothing specific, but you know, I'm a big fan of Nate Silver and 538. I definitely recommend everyone heading to that website, and he's really good at taking a meta view of all the multiple polls and combining them into a reasonable result. And yeah, he's basically the first website I look at each morning recently, and you know, he's saying it's a 90% chance that Biden wins. So we'll see. But he says, you know, 10% is not zero, as we all know.
10% is not zero.
Yeah.
That is what you, the statistician, I'm sure, knows better than all of us, right? So
That's right. That's right.
now,
So
now let's just talk a bit about what it was like for you to build your operator. Can you give us a rundown on how that went?
Well, yeah. So I could talk a little bit about our evolution of where we came from, first of all. So so our product, you know, was not in containers and not using Kubernetes at all, and you know, and that still is our flagship product. So we've come quite a ways of, you know, 8 years and 500 paying customers and exabytes under management, right? With that product, with no containers. But we have been using containers for our testing. So it's really useful to spin up different configurations, right? You might have a 5-node configuration you want to do, and then the next hour you want to do a 12-node configuration, and just doing different testing along there. So we built up a lot of experience with Docker and on that side, but even at that stage, it was no Kubernetes. And then we started to see a lot, first a trickle, and then more and more interest from our customers and prospects of, you know, hey, you know, we're standing up a set of apps using Kubernetes, and we like it for its ease of management. Essentially, you know, it's really easy to use. And then also a lot of our customers started saying, you know, we like the security features of it. You know, we could wall it off. We could do like regular reboots of everything once every day or once every week, and then we all get the same environment. So that triggered us to start saying, okay, we have to start paying attention to this market and investing and building something that will support the market needs there. So our first foray, it was to just build an operator. It was actually forked off the AWS S3, I don't know the correct name, S3 bucket provisioner operator. And that allowed some Kubernetes applications to use the standard Kubernetes resources like CRD, secrets, to access our existing HyperStore software. So HyperStore software is Cloudian's product for object storage. So that was outside still. And that was released in this past summer, and we've gotten some use cases of customers using that. But that in itself is very limited. And then in terms of how much Kubernetes can manage the object storage software itself. So that's when we started a brand new product to deploy our object storage software as a container itself, right? So basically taking what we had been doing internally for testing and deploying that, and then building a full-fledged operator to integrate with that. So that's where we are now, and that's we have announced that and plan to launch it in December of our integrated production-ready operator with our HyperStore software as a monolithic container. So that's where we are right now. And then where we see going forward is that we'll continue on this, and instead of having a monolithic container, so what I mean by monolithic container is it includes everything that would be put on a physical node of our software. So that includes CentOS, it includes a bunch of different services all running inside that single thing that makes it easier to manage. But then as we go forward, we want more flexibility to take advantage of a container infrastructure where we could spin up, say we need 5 S3 services, but we only need, say, 2 storage services, something like that, and do it dynamically. So that's where our roadmap and our plan for the next year is taking us. But so that's sort of almost background. The operator itself has been very interesting to me, and it's doing quite a lot of different things. So one is basically service creation, right? So it would be able to take in and a CR saying, this is how many nodes I want, this is how much storage I want to provision, this is how much the different storage policies I would use, and then it would create those pods out. But the more interesting and sort of involved part of the operator is all the failure management, and it's been quite interesting to do the different types of failure management in that. Well, I could talk a lot more about the failure management.
Can you dive into what that is a bit more? What is this failure management, and what was it like creating that?
Yeah,
were there hurdles?
Right. So in storage, I mean, one of the easiest ways for us to think about it is that there's 2 types of things that could become unavailable, or 2 types of failure zones. So one is a whole node goes out. So in a traditional, I should describe sort of how we are doing distributed storage, but there's 2 standard ways. So one is just replicas. So you might have 3 replicas of the same object across different nodes. And then another way is erasure coding, but erasure coding is basically the same thing. You just might split up a single object into, say, 12 or 6 different pieces and store those on different 12 or 6 different nodes. So one unit of failure is a node. So when we say a node, it could be the node, exploded, or more typically, it's just the network is cut, or some component of it is out that makes it, unusable. And then the other type of component is a disk. So inside a node, you have multiple disks, and they may be virtualized, or you might have some sort of protection at the hardware level at RAID or something like that. But at its core, it's a single disk or volume. So back to what the operator does with the failure management then is you have to think carefully about when each of those, when say a node is unavailable, what do you do, right? So the standard thing in Kubernetes would be, let's just start up a pod on a spare node, and then go forward, and all was good, right? We wanted 3 pods, we had 2, we created 1 more, and boom, we're all good. And that in principle, that's fine, and it works okay and for stateless applications. But as people in storage well know, for when you're dealing with a lot of storage and disk, that is a high cost operation, right? You have to then migrate your data onto this new pod. And so with an operator, then you could think about what sort of knobs do you want to have, or configurations, or other types of flexibility to allow the user to configure that. So one obvious one is, how long do you want to wait before giving up on this node and then migrating it to another pod? So in what happens in production systems often is you get glitches, right? Someone turns off the power periodically, or you have a network glitch, and then your alert systems, monitoring systems start beeping that this is offline. But then, if you just hold off and wait 3 minutes, 5 minutes, then all's okay, right? So that's one type of control, right? That you want to have a simple, what we call rebuild timer. And that's one of our configurations in our CR that you could set up, and it controls at the operator. There's other questions about how does the operator assess whether the system is available or not. So in a distributed system, it's not a trivial answer of just counting, seeing that all nodes are up, or all pods are up, or all pods are down. It's, we're dealing with different consistency levels of data. So you might have a strong consistency level where you want to make sure that what you read is what you have previously written, or you might be willing to have an eventual consistency model where it's not so critical that the data that you read has been written immediately, as you might be able to be willing to accept a lag. So for our storage system, you could have multiple ones of these, what we call storage policies, all in the same system. So you could have, one set of S3 buckets, say, these are eventually consistent, we're just saving them for log data, but these are banking transactions or other type of critical data that we need strongly consistent. And those are all overlaid and put on the same data, on the same underlying storage. So
nice.
How do you assess that and manage that? So that's a lot of the logic that goes into the operator, naturally. So in our standard system, this would be at a more of a control layer, but with Kubernetes, we could take advantage of the Kubernetes sort of reconcile loop or the management loop, and then be able to take care of a lot of that at the operator level. So that's part one of the story. Sort of, please interrupt me if I'm going off too much on a side note, but
no, this is awesome.
Okay, so in the normal case, you have that simple question of, I'm going to wait, say, 1 hour, 60 minutes before migrating a pod. And then there's another question of, maybe I don't even need to migrate that pod. If I already have enough redundancy from my erasure coding and my storage policy allows it, then I'm just going to leave it and then wait for it to recover, or wait. We're doing alerting at the same time. So then we might want to require human or user intervention to decide what to do as best. And then what if there is no spare capacity to spin up a new pod, right? That's another question, right? So if you're not dealing in a elastic, say, public cloud environment where you could just spin up a new VM, this becomes an issue, right? So in enterprises, they have fixed number of, here's your 12 physical nodes, that's all you have, right? So use it all. So if something goes wrong, then what, right? So that's another question that we're working on the operator to figure out and sort of parameterize what can be done in those different cases. So that's one of the considerations for node failure. There's other things like cascading failures. So you're dealing with one pod failure and then another pod goes down. So what do you do then? So there's also questions like that of what to do, which we're taking in all our experience from our large clusters and our production experience to apply to that. But I wanted to get to the other part, which is kind of interesting, is where a disk fails. So if you look at our object storage systems in production, this is the most common error condition, right? So disks die, right? You could see the survey that something like 2% of disks fail over 1 year. So when you're talking about storing petabytes of data, we're talking about disks failing daily or even hourly for certain things. So one aspect is you of course design your system to be resilient to those types of disk failures through redundancy and even hardware RAID and other mechanisms like that. So ideally, you want the situation where the operations guy, right? He doesn't get beeped in the middle of the night, but comes in at 9 a.m. say, this disk is broken, this disk is broken. Pop it out, slide one in, and you're all good to go until the next day. So in a Kubernetes sort of managed type environment, the operator needs to look at what happens when a disk fails as well. So I see a lot more in the Kubernetes environments where the disks are virtualized, where a single physical disk failure could affect multiple virtual volumes, PVs, right? So there's different aspects of what we want to do there. So for example, if a disk fails in a single node and then there's spare capacity on that same node, we just want to mark this guy as bad, this PV as bad, and just recreate a new PVC on that same node. And then at the worst case, if there's no spare capacity or if multiple PVs are bad, then we want to again think about migrating to the pod to a new location. So these are the types of logic that the operator is taking care for us right now. So I would say for our operator, probably 90% plus of the sort of code and the logic is really around this failure management and failure handling, which is as it should be, I suppose.
Yeah, with that in mind, and some of the things that we come across frequently in our community is why it's so intimidating for a lot of people to start even thinking about data on Kubernetes. Just to touch on something that I saw from listening to some other interviews of yours, is your favorite book still the Checklist Manifesto?
Yeah, it is.
From Atul Gawande.
Very documents and find checklists all over the place.
Sure. But with that in mind, one of the things you talked about in that interview is how there are two types of fundamental errors, one of ineptitude and one of ignorance. In terms of approaching, data on Kubernetes, like I said, which is quite challenging, even overwhelming for some people, do you find that it's a lack of contact, which might cause, issues of ignorance, or ineptitude that we're talking about leveling up in terms of skill?
Yeah, I would say it's more of the latter, ineptitude, and not in a sort of negative sense. It's almost in the sense that the problems haven't been thought about deeply enough yet. And I don't think there's that much, I don't think there's, for example, there's petabyte level object storage systems managed by Kubernetes right now. We want to fill that void, but I think there's still some, there's not the knowledge yet that of some of the complexities of managing such a large amount of storage underneath with that. Yeah, I think, I mentioned, for storage administrators, one of the sort of never to do rules is, you try to avoid moving data because moving data, a lot of bad things can happen, right? I mean, you could have new errors come up, you could lose data in transition, or a lot of incomplete things. New data is being overwritten on top of it. Things like that happen, and those are the types of things that I think have to date been, I would say, underestimated in what I see in the Kubernetes data side. But I'd say that's sort of a natural and correct evolution. Now we're starting to work and face these type of issues and challenges, and I think it's good. So I think this community is helping in that respect as well. So it's great.
Yeah, that's definitely what we're going for, because as you just laid out so eloquently, it's not the easiest thing. There's a lot you have to keep in mind, especially for failure, right? When failure happens, you need to be aware of how you're going to go about putting the pieces back together in a logical way, and a way that gets everything back up and running like it was, and you don't lose anything. And I'm just wondering, when you talk about how there's not really these petabyte sized object stores that are being managed by Kubernetes, is that something that you feel it's not happening because the market's not there, or is it not happening because it's just too difficult right now, and it's like there are people that need to trailblaze a little bit like what you're doing?
Yeah, so I think it's coming. So I think we've seen the advantages of managing apps using Kubernetes. So in particular, where I think this fits the best is with analytics. So for example, like a simple LiDAR rig on a autonomous vehicle, it's generating all this data, right? So that data needs to be stored, and then it needs to be analyzed. And these two, one without the other, doesn't make sense. So this is a type of thing that's just growing and growing in terms of volume and capacity and need from the application side. So having Kubernetes useful as a management layer and as to do things like RBAC and enforce security through namespaces and other things, I think is a very useful framework. But I guess what I'm saying is that it doesn't sort of help with a lot of the underlying storage the issues brought by, and the complexity brought by with storing a lot of data. So yeah, there's a lot more interesting work to be done by all of us.
Yeah, and that is, I just saw a question in the chat. It magically disappeared. I don't know if it was answered, and
no, sorry, because I responded.
Okay.
Yeah, it's from Asif. Thank you very much for your question, Asif. And the question is, Gary, what are your thoughts on solutions like Portworx?
I think think they're good. They're all very good. I we've looked at that. I it's a matter of, you know, how, at one sense, you know, what Portworx and others are driving is open standards that where we could access a lot of this data, and that's definitely where we want to go. So
yeah, like you said, but by no means it's not the only solution. I mean, we also have other alternatives such as OpenEVS. There are different things in terms of options, but just as, you know, what are the situation you might find yourself in when you might want to be considering those things?
Yeah, a lot of it. So a lot of it I guess, you know, I have a limited view, and a lot of it's just informed by what I see our customers and our prospects asking for. So, you know, a lot of it is just they want to avoid any, say, vendor lock-in, right? They want to be sure that whenever they have anything storage, they have some flexibility of being able to, you know, if this vendor doubles its price next year, they want to have some flexibility and risk management to be able to switch off into something. So that's the main type of consideration that I see coming out of the market. I see the same thing with the public clouds. So a lot of companies now are starting to realize that their dependence on, you know, say AWS, right? So it's not so much that it's a cost issue right now, but it's a more of, you know, say if I'm Walmart and I'm a competitor of Amazon on the retail side, you know, what do I do, right? I want to avoid this type of sort of dependency on one type of company, or so that's why the more and more that we could push a sort of plain open source flavor of Kubernetes, and how we could make our software work with those types of frameworks, I think is all good for our community and everyone's sort of development.
So I'm wondering about the idea of most people starting with Kubernetes and starting small, and then maybe scaling up and getting bigger. And what is your plan to, like, kind of try and capture the smaller, I guess, market? Is there a plan to do that, or do you want to just stick with a certain range once it's gone above petabytes?
Right. So we come from the enterprise side, from the petabyte side, where, you know, we're charging a lot of money for a lot of storage, essentially. But we do see, we want to, as I said a bit at the start, is like people who have storage never decreases, right? It just grows and grows and grows and grows. So even on the enterprise side, we've always had the philosophy of being able to start small with you know, VMs and a small amount of storage, and then as the need grows, you know, that capacity will grow and we'll make money. Now, I want to tie that in of what we see at the Kubernetes. So Kubernetes in itself is a very open source driven community, and that's good. So what we as Cloudian have also been looking at is how can we support and get into that via an open source type solution. And that's, you know, I don't want to jump the gun, but that's definitely something that we're very interested in and are thinking about of how to support that, and how to provide that type for small starts, especially for projects that are not necessarily, you know, commercial and enterprise and making money right now. So with that very interesting question.
Yeah, with that in mind, how do you see the development, or, you know, the current phases or where we're at right now with you know, storage as a service, and how that's going to be evolving?
Yeah, so storage as a service will continue to grow, but what we see and what I think everyone sees is that there's so much data being generated at the edge that you can't put it into a public cloud, for example, or it's even difficult to put it into a data center in a private cloud, right? So I could go back to the autonomous vehicle example, right? There's 12 terabytes of data being generated a day. Just even with 5G, it becomes really unwieldy to start transferring this data to somewhere. So what I've been talking about is more data gravity, where the data you don't want to move, right? The data is what you want to move the compute and analytics jobs to. So in that respect, I think edge computing will sort of become, I mean, the word edge will sort of drop off because that'll be the more ubiquitous type of computing in the future. So we have certain customers, for example, that have thousands of temperature sensors out in fields, right, that are just generating right now a small amount of data, but I think of that growing and growing, and this whole idea of having to centralize that data and store it all in one place, it just doesn't scale. So we need both the ability to store data and compute on that data at the edge, at the middle, and at the public cloud. And how we develop that architecture, I think is still open, but one of the things that drew us to Kubernetes is the opportunity where we can make a small edge processor that has some amount of object storage, and then some amount of analytics processing capability, and then control through Kubernetes the amount of resources, compute resources, like I'm talking about CPU percentage and memory percentage inside that small form factor, and then distribute those out, right? So that's where we think this market is going to explode. And in order to do that, we have to get much better at, well, first of all, we have to figure out a lot of things about on how to do Kubernetes better. We have to really improve our distributed systems work. And what I mean by that is, again, the uncertainty and failure management part, right? I mean, if everything's connected and working perfectly, the problem's very easy. But the problem always becomes when, things break, things fail, and how to replace it. So, sorry, long-winded question, but storage as a service will continue to grow. But I think what'll grow faster is the sort of edge storage and medium storage that need to be connected to that.
Okay, and can we dive a little bit deeper on data gravity as someone who doesn't have a PhD? Could you, I mean, just conceptualizing some of these things at first, when I first started reading about it, I was like, okay, we're talking about laws of, physical science applying to things that I can't see that aren't tangible. Could you go a little bit further on that?
Well, think about it. So for example, we're doing a small project on air sensor. So we have a bunch of air sensors in different places, and they're collecting data. So the data is collected at these different places out in the environment. And one way to solve this problem is to collect all that data, push it all into, say, the public cloud, and then analyze that data for, say, some trends on different levels of different gases or whatever at that public cloud. And that works that makes sense if you're not sensitive to timeliness, right? Because to transfer all that data itself, some sensors might, be on a, weak, network connection is very difficult, right? So so if you think about that, it's heavy work to move that data across to different places, and that's what I mean by data gravity, right? So instead, the easier way to think about it is the data is all being generated out by these sensors, and it's much easier to take my 100 lines of analytics code and push it out to that data and have these little Raspberry Pis run that small compute jobs out there. So it's easier to move the compute to the data than move the data to the compute. So that's what we need to sort of reason about to figure out, what's the right combination of what to do at which level of this spectrum from edge to private data centers to public clouds. And to the extent possible, what we want to do is to avoid moving the data, because the data has this gravity. So one of the simplest ways to do this is filtering. So we see a lot of this going on right now where 90% of the data or 99% of the data being generated from the sensors, we could just filter out right at the sensor, right? Because, okay, the O2 level is at a nominal rate, so we'll just throw that away. But this one is anomalous, so we're going to send that off for further analysis. So that type of simple analysis that we could do at the edge to reduce the amount of data being transferred and sort of being able to generate better quality and smarter data as we move along. That's a good principle that we want to do. And then the other thing, just to finish this point.
Good. Keep going.
Yeah. This is a loop, is what I wanted to say. So what we want to do is do our heavy lift of, say, machine learning or deep learning. Say we run that training and construct new models, say on a slower loop at a central place where we could gather data from a lot of different sources. But then once we do that, we compile it into a machine learning model that we could push out to the edge processors, and they could use that for most of their computation. So we have this nice feedback loop where the system eventually gets smarter over time.
Amazing. I love this idea of, and I'm going to quote you on this, it's easier to move the compute to the data than move the data to the compute.
Yeah, that's absolutely right. And it's not only a matter of time, but it's cheaper. So what I say, it's faster, it's cheaper, and it's more secure. So the more secure part often gets lost, but what we don't want to do is say we have hospital records or medical records. Think about them being generated at the hospital or the clinic. Every time, if we say, hey, let's put all of our medical records in this one public cloud, that's sort of, raises alarm bells or should raise alarm bells, I think, for everybody, right? We want to put all our most sensitive data in one location, controlled by one company. Need to consider that.
Re-examine that statement or that decision. Right. Definitely. Now,
right.
Well, you were talking about edge processors, and I know that before we had mentioned we wanted to talk about partially networked edge processors a little bit and running compute and storage on them. Was that what you were getting into, or can you dive into that a little more?
Yeah, so that's what I'm talking about. So by partially networked, the idea is we need to give up on this idea that everything is perfectly connected to each other and able to communicate at 5G rates to each other, right? We have these edge processors or edge devices that are out there that you have to be able to operate autonomously. I mean, again, back to the autonomous car example, right? You don't want to go back and send all your sensor data back to a central place, have them say, okay, turn 20 degrees now, and then have that sent back through the network back to the car to make that decision. So we have to think about how do we operate in these error states as much as possible independent, but then also not giving up that idea that we also want to take advantage of when we are connected, how do we get smarter? How do we learn from the experiences of all the other autonomous cars out there and build better ML models that we could push back down at the next update to my vehicle. So tying it back to Kubernetes, that's what I'm hoping and looking for Kubernetes to be able to help with, where we could have these lightweight management of compute and storage all on the same devices and same edge processors. So I'm very interested in more lightweight Kubernetes type applications, because I feel that's sort of where the need is, and where the more difficult problem is of how do we make it as lightweight as possible, this management layer and control layer on top of these processors. When we have back at a data center or a hub, when we have a lot of compute resources and reliable networking, it's sort of less important that we have a management framework around it or an orchestration layer around it. It's much more interesting problem to do it in a resource constrained environment. So
yeah, that reminds me, I talked with people in a past life about, they were working for a company that did shipping, and they would put the models on the edge on these shipping boats or ships and they would not have connection, so
right.
they would lose connection maybe 2/3 of the time, and they just had to make sure that they had that stability there. And I think that's a great example of what you're talking about. Like, you can't be expecting it to go from here and then back to some centralized place and then push it back and make the prediction, especially when you're talking about machine learning. It needs to be doing everything right there at the edge. And it's cool to see that Kubernetes, you're bullish on it as something that could be really interesting for that.
Yeah. I mean, just this morning I was listening to a podcast where they were talking about collecting rock samples from an asteroid, right? And I was thinking, that's the same exact problem, right? I mean, you have this very laggy control lever, right? That you just cannot rely on to do things. But you want both.
Yeah, that's interesting, because when you can take advantage of it, you want it to be there.
Right, exactly.
So I'm gonna default to Bart because I just choked on my water, so I'm coughing a little bit.
Yeah, I got one question. Then we're almost getting to the end, so we got something to finish up with. But tomorrow we're actually opening up a different conversation with some of the people in our community. We got people from about 4 or 5 different countries, and we're going to be meeting tomorrow just to talk about the issue of cost control and different things to keep in mind when running data on Kubernetes. Now, you mentioned several times different things that can come up in the realm of storage. But generally speaking, whether it be at storage or other things, keeping costs under control in Kubernetes, particularly when considering data. Any advice that you might want to give to the community about that?
It's interesting. So one thing I would say is always think of the cost of operation. So I think the Kubernetes community is a bit more advanced and understands this much more than others because of, sort of this DevOps focus and DevOps roots. But often I see, let's say groups that are looking, they want to push down, say, the initial cost of a system, to win a bid, but then, it ends up costing more because you're constantly patching it and dealing with the problems as you run it into operations, right? So when you look at cost, it's not look at the cost over time. And with storage, it almost always comes, there's always this natural tension between engineering and sales, right? So sales wants the deal, so they want to drive this cost down. But then what the tension is that you might be selling an under provisioned system, right? So typically in storage, it's your system is so small, is too small that you're not thinking forward about this operational cost of at what point do I have to expand the cluster, and how many hours of my storage admin do I need to run that operation and do that and babysit it. So this gives me a good opportunity to talk about this point of how I'm always talking internally in my company of, always think of sort of the cost associated with sort of the long-term of the system, right? The lifetime of the system. And for storage, as we said, you want to build a system that could grow and grow and grow and grow and keep on growing to the end of time, right? So having that initial thought when you're looking at the cost and the cost control, I think is critical.
That's a great point. And a lot of times we talk about these things, it's sometimes it's a cultural question. And like you said, when you have this sort of friction of sales is pushing for one thing, engineering pushes for another, but a lot of things is like, look, we might be thinking about the first couple of months, but ideally we're going to be working with this for years and not have to change. So I think that's a great point to keep in mind. Dimitri, do you have any other questions, or can I jump to the other?
Yeah, no, I know Bart has some cool stuff that he's going to share with us. So feel free, Bart.
Okay, cool. So this is the first time that we've had a graphic recorder with us. And so while we've been talking, a friend of mine named Angel, who's helping on the community, he was jotting down some ideas and drawing a couple things. So I'm gonna share my screen really quickly. Yeah, thank you very much, Angel. So let's see if everyone can see this. Can you see my screen?
Wow. That was done today.
This was done simultaneously. So yeah, we still will get the quote in. We will still definitely get the quote in there, but it's easier to move the compute to the data than the data to the compute, because I think that's going to be a nice sort of title that we can have overarching everything. But I think it was a nice sort of synthesis. I also made sure that Angel got Cal in there, even though you're not wearing a Cal sweatshirt. It's very important to have that in there. So anyway, but this is something that we want to keep doing from time to time so that we can get sort of these core elements of the insights that are being shared to make it easier for people to jump in, because this is what this is all about, is building a community and having fun.
Great.
Super
Thank
awesome.
you. It looks beautiful.
Yeah. So in case anyone here is not in our Slack channel, I'm just going to post a link if you want to join the Slack community, because we're having all kinds of conversations there. And like Bart mentioned, that groups are starting from there to help discuss ideas around cost optimization. We also have, cool videos that we've been sharing along the lines of different metaphors that people come up with that just spark ideas in our minds. And we say, wow, we can make a cool little animation video on that. So if you're not in it, jump in it. I definitely think it is a good use of your time to waste time in our DoK Slack channel. And Gary, man, thank you so much. This has been an enlightening conversation, and I really appreciate you sharing your wisdom with us.
Yeah, on a day with so much uncertainty, I think we're leaving this with a fair amount of certainty about a lot of really important stuff. So anyway, thank you so much.
Thank you guys. Had a good time.
We will see you
Perfect.
later, and hopefully everybody that's in North America goes out there and they vote, and we will see you all next week, same time, same place.
All right. Take care. Thanks, Gary.
Cheers.
Bye.